So, what? Chapter 6? Yeah. I am. Chapter 6. I will. All right, gentlemen. Ian. All right. Inverse functions. This whole chapter, we're doing chapter 6, is on inverse functions. I will warn you, you're going to want to rememorize your table for this chapter.
Are you kidding?
Yeah, you're going to want to rememorize that stuff. Huh? No, we're skipping chapter 5. Unless you want to. I can do chapter 5 if you want to, but it's just more proofs. So, all right. So chapter 6, yes, you're going to want to know your table. What is an inverse function? No, it's not so much a different answer. Remember, this is the discussion about, remember the inverse toaster discussion that we had earlier this year? I think you guys were the toaster discussion. What's the inverse function do then?
Put y in, or you would put x and you get y, but for this function you put y and you get the x.
Right, so it basically undoes. So let's say I have some function. I don't know what that function is, okay? But if I plug in a 2 and I get out an 8, then what should happen with its inverse function? Where if I know the inverse of f of x, and I'll call it f prime of x, if this is the inverse of that, a different machine, what should I be able to do? If I plug in now an 8, what should I get out? A 2. So an inverse function undoes what the original function did, right? Where we talked about earlier this year when we did inverses, like a toaster. What would an inverse, so a toaster, what's the input? No, you don't put toast in a toaster. You put bread in a toaster. You put cold bagels in a toaster, right? What? Yeah. Tuesday.
Yeah.
Yesterday, yeah.
And then took the test today.
Right.
Can we imagine we did that?
No, no.
You don't got it.
I got it.
We could have done the test.
You're right, but you chose. You made a choice. Live with the consequences. You gotta live with the consequences.
Mr. Big, we don't have a whole lot of time left in the hour.
I know. I'm not actually going to get all the way through this. I just want to kind of get a start to it. Because if I start it now, I'll get through it faster tomorrow, and then you'll get homework tomorrow, and then you won't have homework because I'll give you lots of time in class.
Okay. So that's like saying, I'm going to pour myself a bowl of cereal with the milk in it, right? You know?
But this stuff doesn't get soggy.
Eat half of it, and
No,
I'm going to leave the rest for later.
Which is fine as long as it doesn't get soggy.
And then you're going to have to figure out
This stuff doesn't get. This isn't cereal.
combine your videos. You're starting a happy video.
Yeah, you might as well just
You gotta redo it.
Yeah.
You know, I'm just trying to make. You don't want to do video editing and stuff. That's not your table.
Actually, I kind of enjoy it. I really do. I kind of enjoy video
Well, you're
editing.
gonna have to crop all of this conversation out.
That's easy. That's really easy. It's actually a really easy thing. Okay. No, I'm doing this. I'm doing this.
I have one quick question.
1972. Okay.
No, when did you decide to make yourself
Bald?
Yeah.
Or kind of bald?
No,
Mostly
take it
bald.
all off.
Well, I've only recently, like a few months ago, went bald, like razor bald.
Bald.
No, you were definitely bald at first.
Yeah.
But I never used like a straight razor. Like I didn't go smooth. I went with the clippers. I just basically went like no guard.
So when did the eyebrows go?
Oh, that was 1984. Okay.
Do you like it better, bald, or did you
Yes.
You used to talk all about how you had a full haircut when you had the reversal on. And now you cut it off.
And you can still kind of see where it was. Like it stains and stuff.
This how I haven't gotten this far.
I'm illiterate actually. I don't do the same.
What is y? What is 7x squared plus 1?
No, we just had a test.
I know. I know.
Like,
Uh-huh.
no, you're going out on the
Test
favorite teacher
today.
list. I would know that.
Got still stuck
Steady
on how.
decline.
He doesn't care.
Okay.
He doesn't care about it.
So how do you find an inverse function? How do you find an inverse function? No, how do you find it? So if this is my function, how do you find it? Kinda, but you're skipping a few steps. You're thinking about how do you get directly to the answer, but there's an easier way. You rewrite the function exactly the way it is. But what is happening with inverse functions? So what just happened with this problem? What? Yeah, the x's and the y's just switch, right? So like the x became the y became the x, right? So the way you find inverse functions is exactly that. So you have basically x equals 7y squared plus 1. Now, we don't ever write functions with solve for x, right? So we got to resolve this for y, which would mean I would minus the x, or minus the 1, divide by 7. So you're going to get x minus 1 divided by 7, square root that. This is going to be the inverse function of that. Yes?
So if you're solving for y, you have to like, I mean,
Because now I have two different functions. So
He's asking the real question.
I'm getting there. I'm getting there. So these two functions now. 7x squared plus 1, square root of x minus 1 over 7. These are inverse functions. So what that means is if I plot points, if I plug in a 1, 1 squared is 1, 1 times 7 is 7, 7 plus 1 is 8. So I plug in a 1, I get out an 8. What should happen over here? Bless you. If you plug in an 8, what should I get out? A 1, right? So if you plug in an 8, 8 minus 1 is 7, 7 divided by 7 is 1, square root of 1 is 1. Absolutely it works. If you plug in a 2, 2 squared is 4, 4 times 7, 4 times 7, 28, plus 1 is 29. So what should happen over here? If you plug in a 29, you should get out a 2. Now, graphically, what ends up happening, you guys remember what happens with inverse functions graphically? No, it doesn't go upside down. So what ends up happening graphically, if you have 7x squared plus 1, this, we all know, is going to be a parabola. It's going to be a pretty skinny parabola that looks like this, right? All x squared graphs are parabola graphs. What do you think this graph would end up looking like? It's not so much as upside down as much as it is, come on, let me, like this. Now, my question to you is, how does graph 1 become graph 2? What is the relationship that this graph over here became this graph over here? What does it look like it's doing? It looks like it's rotating, but it's actually not rotating. And I can prove that to you by looking at one point. Take the point 1, 8. That point on this graph, 1, 8, is basically right there somewhere, right? Well, then the point 8, 1 is like right here. if that was a rotation, where would that point actually be located? Wouldn't it be in the fourth quadrant? It'd be down here, but it's not. So it's not a rotation. So what actually is happening, and this is true for all inverse functions, is it's a reflection. It's a reflection across the y equals x line. Basically, what ends up happening, this point here gets reflected across the line and ends up down there. This point up here gets reflected and it ends up down there. Okay? Basically, the y-axis becomes the x-axis. This is true for all inverse functions. This is something actually you should already know. Like you should have talked about this kind of concept in Algebra 2 of how the graphs relate. Why is this important to us? Because now we're talking this. Okay? What's the inverse function of that? Well, the inverse function of that is this. How do we say that? We've been using it all year so far. That's inverse sine. Another way to name this, these two things are actually the exact same thing. It's a notation thing. It's some books, some mathematicians don't like this notation. Some mathematicians write it this way. We'll talk about why tomorrow.